Since the dawn of the space age in the 1950s, we have launched thousands of rockets and sent even more satellites into orbit in more than half a century. And many are still there, and we face an ever-increasing risk of collision as we launch more. Since humans began to explore space, they have also begun to litter it. As long as humans have been exploring space, we have also been creating a bit of mess. Orbiting our planet are thousands of dead satellites, along with bits of debris from all the rockets we have launched over the years. This situation is a real danger today, both for terrestrial telecommunication and for ongoing missions. A space debris or a space junk encompasses both natural meteoroid and artificial orbital debris. Meteoroids are in orbit about the Sun, while most artificial debris is in orbit about the Earth. Orbital debris is any human-made object in orbit about the Earth that no longer serves a useful function. A space junk has been missing since the first human-made satellite, a Sputnik 1, escaped Earth's gravitational pull on October 4, 1957. The momentous event start of the space age as humans begin to explore ever further away from our home world, and this is a feat that has been repeated in more than 4,700 launches around the globe. But that also means we have left our mark on space in the form of trash. The space debris not only include the objects such as dead satellites that have failed or been left in orbit at the end of their mission, but it also includes smaller bits and pieces lost to space, including paint chips that flake away from the outside of devices, mission-related objects, for example nuts and bolts, garbage bags, a lens cap, a screwdriver, and even a spatula. Currently, there are 2,000 active satellites and 3,000 dead satellites in Earth's orbit, which serves no purpose anymore. Below 1 centimeter, it is estimated that there are more than 128 million of these fragments, and most of them are undetectable. Between 1 and 10 centimeter, it is calculated that there are around 900,000 in orbit, which ranges from the size of a marble to a tennis ball. And more than 14,000 space junk larger than 10 cm objects include everything from tools lost during mission to defunct satellites are tracked by the United States Department of Defense with the Global Space Surveillance Network sensors. And much more debris are too small to be tracked but large enough to threaten human spaceflight and robotic missions exist in the near-Earth space environment. Most of that debris sits between 1250 miles or 2000 kilometers of Earth's surface in what is known as low Earth orbit. The low Earth orbit is home to lots of satellites such as NASA Earth Observing System, which is designed for long-term global observation of the land surface, biosphere, atmosphere and oceans, and the International Space Station is also located in this region. While space is big, so even 23,000 fragments tend to be far from each other. Even the tiniest bits of minute flotsam can be problematic for active Earth orbiters because of their breakneck speeds. The speed at which these debris and spacecraft move is more than 28,000 km per hour, faster than a speeding bullet fast enough for a relatively small piece of orbital debris to damage a satellite or a spacecraft. All space junk in the Earth's orbit is the result of us launching objects from Earth, and it remains in orbit until it re-enters the atmosphere. How long a piece of space debris takes to fall back to Earth depends on its altitude. Some objects in low orbits of a few hundred kilometers can return quickly. They often re-enter the atmosphere after a few years, and for the most part, they will burn up so they don't reach the ground. But debris or satellite left at higher altitude of 36,000 kilometers, where communication and weather satellites are often placed in geostationary orbits, can continue to circle Earth from centuries or even thousands of years. A space junk results from collision or anti-satellite test in orbit. When two satellites collide, they can smash apart in thousands of new pieces, creating a lot of new debris. This is rare, but several countries, including the USA, China and India, have used missiles to practice blowing up their own satellites. This creates thousands of new pieces of dangerous debris. The rising population of space debris increases the potential danger to all space vehicles, including to the International Space Station and other spacecraft with the humans aboard, such as a SpaceX Crew Dragon. The risk of a catastrophic collision of a space shuttle with a piece of space debris was 1 in 300. For mission to the Hubble Space Telescope with its higher and more debris-filled orbit, the risk was 1 in 185. If there is a greater than a 1 in 100,000 chances of known pieces of debris colliding with the International Space Station. On July 24, 1996, the first collision between an operational satellite and a piece of space debris took place when a fragment from the upper stage of European Ariane rocket collided with the Ceres, a French microsatellite. Ceres was damaged but continued to function. The first collision that destroyed an operational satellite happened on February 10, 2009. when Iridium 33, a communication satellite, collided with the Cosmos 225 band, an inactive Russian military communication satellite about 760 km above northern Siberia, setting both satellites and bursting into a cloud of thousands of pieces of debris. The worst space debris event happened on January 11, 2007, when the Chinese military destroyed the Fenghuan 1C weather satellite in a test of an anti-satellite system, creating more than 3,000 fragments, or more than 20% of all space debris. Within 2 years, those fragments had spilled out from Fenghuan 1C original orbit to form a cloud of debris that completely encircled the Earth and that would not re-enter the atmosphere for decades. With some of the junk we lost altitude over time and burn up in Earth's atmosphere, there is a lot of stuff up there. Even without new launches or major explosions, the space junk already in low Earth orbit is so abundant that could result a chain reaction, also called Kessler syndrome, where more and more objects collide and create new space junk in the process to the point where Earth's orbit became unusable. Computer simulations of the next 200 years suggested that during that time, debris larger than about 8 inches across will increase by 1.5 times, but the smaller particles will increase even more. Junk between 4 inches and 8 inches is expected to multiply 3.2 times, and debris less than 4 inches will grow by a factor of 13 to 20. We have become increasingly reliant on the growing constellation of satellites up above. Not only are they invaluable for science, but use of them for communication, navigation, weather forecasting, and more. So rather than halting future launches, researchers have been investigating an array of methods to both remove and reduce space junk. Many ideas have been proposed for some time, and one of the most serious ones involves capturing and returning the mission being tested. These include removing dead satellites from orbit and dredging them back to the atmosphere, where they will burn up. Ways we could do this include using a harpoon to grab a satellite, catching it in a huge net, using magnets to grab it, or even firing lasers to heat up the satellite, increasing its atmospheric drag so that it falls out of orbit. However, these methods are only useful for large satellites orbiting Earth. There isn't really a way for us to pick up smaller pieces of debris such as bits of paint and metal. We just have to wait for them to naturally re-enter Earth's atmosphere, while making sure that satellites are removed from orbit in a reasonable amount of time. Once they are no longer active, we can mitigate the problem of space junk in the future. Earth's orbit allows us to study our planet, send communication, and more. It's important that we use it sustainably, allowing future generations to enjoy its benefits too.